We just covered how to initialize and build up an axis-aligned bounding box from geometry. In this short little episode, we're going to look at code for the query functions, hit testing and finding intersections. So remember that one of the main reasons to use an axis-aligned bounding box is to give a computationally cheap way to determine if a point is possibly inside the shape or not. Another purpose is to check if two boxes have an intersection. If they do, it might mean that the two shapes are colliding. So here I'm only showing the hit test function's documentation and signature. So we have a plain English description about what it should do, and we can see that it takes an axis-aligned bounding box called box and two numbers called x and y. And we also see that the function should return a Boolean. But there's no implementation because I'm a mean person. So think about what we've already covered. The box has min and max x and y fields. How would we use those and compare them to the input points x and y values? So in English, the x value is inside the box if it is larger than the box's minimum and less than the box's maximum. And you can work that out for the same in the same logic for the y value. And the point overall is only inside the box if both of those are true, both for the x and the y dimension. So here I go. I'm being mean again. This is the function in the homework to intersect two boxes minus the implementation part. So in this case, and really just about any situation where it isn't obvious what to do, I recommend the same thing every time. I'm going to turn the camera on to emphasize this point. I'm going to recommend the same thing every single time. Draw a picture. Ask the picture, what are all the ways that two boxes can be arranged? What if they overlap in X but not in Y? What if box A entirely encloses box B, or if box B encloses box A? Then look at your drawings and relate them to the data structure. Each edge in your drawing will represent a minimum X or a maximum Y and so on. And what relationships do you see when you make your drawing? How can you relate that back to code? So keep in mind that this intersect function should return an axis-aligned bounding box. So if there isn't an intersection, you can just return init AABB. If there is an intersection, you'll build a new AABB for the rectangle representing the intersecting region of the two input ones. And again, look at your sketch. Look at your sketch and ask it to visually give you the answers. You've already written code to initialize an empty AABB, so you can use a similar approach to build a new AABB from known values. All you have to do is identify the top left and bottom right corners that model the intersecting region's minimum and maximum points. So with that, I wish you good luck on the homework. If you're in my class, you should have access to this on the course website. It's on GitHub. It's written in TypeScript, and the unit tests that come with it should let you know if your code is doing what it needs to do. So good luck, and I will see you in the next sequence.